Spring Framework is one of the most widely used framework in the industry, so we can expect a lot of questions from this topic in the interview. We will start with very basic interview questions for freshers, and then in the upcoming videos we will cover more advanced questions for experienced developers as well. You can find the list of questions in description as well, and using chapter links given below you can directly access any specific question that you want. Now without any further delay, let us begin. Before we discuss what Spring Framework is, let us understand what a framework is. A framework is like a ready-made set of tools that help developer build software with ease and efficiency. It includes things like libraries, conventions, and best practices. Think of it as a template of working program which we can modify as per our own requirements. We have many frameworks available for front-end and back-end. But a good framework should be easy to understand, consistent, and easy to implement. It should also use best practices and design principles. Most important is it should allow developers to create reusable components. Using a good framework reduces the time and energy spent in developing software applications. Now let us move to what is Spring Framework. Spring is an open source Java framework that supports building robust applications. It provides many tools and libraries which can help in developing Java-based enterprise applications quickly. Spring helps developers create high-performing applications using plain old Java objects, also known as POJO, and servlet containers that speed up the development. Let us move to the next question. The next question is, what are the features of Spring Framework? These listed are the main features provided by Spring Framework. Spring's core technologies provide a framework for managing dependencies, handling events, accessing resources, and many more other features. Spring's testing suite includes tool for creating mock objects that helps in quickly developing the test cases with ease. Spring also simplifies the data access by managing transactions, providing DAO support by integrating with JDBC and ORM frameworks like Hibernate. It also provides support for building traditional servlet-based web applications in Spring MVC and also offers Webflux as a reactive programming model for handling asynchronous web applications as well. Spring also supports multiple languages including Java, Kotlin, and Groovy. Next question is, what are different modules of Spring Framework? These are the different layers or modules present in Spring Framework. Let us start with core container. The core container manages the fundamental parts of Spring. In this we have core and beans, which handles inversion of control and dependency injection that makes our code more flexible. We will understand what is dependency injection and inversion of control in our upcoming questions. The context module builds on the solid base provided by core and beans module. It inherits its feature from beans module and adds support for internationalization, event propagation, and resource loading. The expression language module lets you query and manipulate the objects very easily at runtime. The data access and integration layer connects our application with data sources. It uses JDBC to simplify database access, eliminating the repetitive code. Similarly, it uses object relation mapping, which helps integration with mapping frameworks like Hibernate for database interactions. It also have a module to manage transactions to ensure the data consistency. The JMS module handles the messaging between different applications. The web module handles web-related tasks in our application. It provides a wide range of functionalities from the basic web integration to MVC and also support for the reactive web applications. Now to promote modularization of code and improving flexibility, Spring provides features such as AOP and aspects. Spring also provides support for testing with frameworks like JUnit Mockito. It also offers mock objects for isolated unit testing of your code. So these are all the modules present in Spring Framework. Make sure you understand these components and how they work, because interviewer can ask the next question on any of these modules. Now moving to the next question. What is inversion of control? This is one of the most important questions that can be asked to a fresher as well as to an experienced developer. So what exactly is inversion of control? Inversion of control is a design principle in which the control of creating the object is inverted from application code to a central framework pool. Let us understand this with a real world analogy. Imagine you are baking a cake. Normally you would gather all the ingredients yourself and make the cake from scratch. However, with inversion of control, it's like having a magical kitchen where someone else gather all the ingredients for you. All you need to do is decide where to use those ingredients in your cake, and everything else is taken care of behind the scenes. In software terms, if we talk about, the inversion of control means that instead of your application creating and managing all the objects it needs, the Spring framework manages these objects for you. It inverts the control from your code to the framework. This makes your code more flexible and easier to manage. Now the question is how inversion of control is implemented in Spring. The inversion of control is implemented in Spring using dependency injection. In dependency injection, instead of your code creating the object directly, Spring injects them into your classes. Let us try to understand this with a code example. In this, my application directly creates an instance of data service. Doing this will tightly couple my application to data service class. That will make it harder to change data service or mock it for testing. Now in this example, my application uses dependency injection through Spring's @autowired annotation to inject the data service. My application no longer creates data service directly. Instead, Spring injects the data service bean into my application. Here we can see we are not creating data service object using new keyword. This approach decouples my application class from data service class, making it easier to replace or mock data service for testing. Spring manages the lifecycle and configuration of data service, allowing my application to focus on using data service rather than creating or configuring it. Now let us move to the next question. The next question is, what are the different ways to implement dependency injection? We have these four main ways to implement dependency injection. Let us understand each one of them one by one. Let us start with constructor injection. As this class is annotated with @component, it becomes a managed bean in Spring. That is, Spring will create and manage its objects. And in its constructor, we are setting the data service field value. So when Spring IOC container starts creating an object of my application and finds that it requires object of data service as well, then automatically an instance of data service will be injected to this class via constructor. That is why it is known as constructor based injection. Because the data service is also a managed bean, so Spring will be managing its instances and a bean will already be present in Spring IOC container. And when we are trying to create an object of my service, during that time, the bean of data service will be picked from IOC container and inject into it. Similar to this, we have setter injection. So in this case, the dependency is injected via a setter method. If we see in our previous example, the dependency was injected via constructor. So on the similar node, a setter method of a particular field will be used to inject that particular dependency. That is why it is named as setter injection. The next type of injection is field injection. Field injection is when we try to wire the dependency directly at the field level. Like in this case, we are using auto-wired annotation when we are defining the field. Spring will inject this data service bean at the field level itself. The last one is interface injection. In this, we have data service where contract is defined, which is an interface, and then we have an implementation of that contract, data service IMPL. In our main application component, we have defined a reference of type data service, which is an interface. And at the runtime, using by type auto wiring, Spring will inject the instance of data service IMPL into our main components. This will easily work if we have a single implementation of that contract. In case we have multiple implementations, then we need to use few more configuration tools. There are few annotations which are present like @primary or @qualifier. Those we can use to remove that ambiguity. Now let us move to the next question. The next question is how to define beans using XML. For that, let us take an example. Suppose we have my service class which uses a dependency data service class. Now to define beans using XML configuration, first we need to create an XML file with a root element beans. Inside that we can define multiple bean elements. Here we have first bean of my service class where its ID and class is defined. Class details has to be fully qualified name with complete package details. Then we have one field named data service inside my service class. It is auto-wired using setter injection by using property tag element in this XML. Ref attribute is used to mention the bean to which this property will be wired to. So in this case, an ID of other bean, which is data service, is used. Then we have this second bean element to define the data service bean with all the details required. So by using this, my service bean with a field name data service is defined, and wiring of that field with the actual data service bean is also configured. So when Spring application is started and IOC container is being set up, objects of these beans will be created and injected as per the configuration given in this XML. The next follow-up question could be whatever we have just done using XML, how the same can be achieved using annotations. So for that, let us try to understand it again with an example. We have used @component annotation on my service and data service classes. When Spring scans these classes, it will see component annotation present and will mark them as managed beans. The complete lifecycle of objects of these classes will be taken care of by Spring IOC container, which will serve the same purpose of defining a bean element in an XML, where we are giving ID, class, and other details. Now comes the second part where in XML the wiring of dependent service using parameter tag was done. For that we can use @autowired annotation. So when Spring encounters @autowired annotation on the constructor of my service, then automatically the required dependency of data service will be injected from the IOC container, which will have similar effect of using constructor-arg tag in the XML for wiring the beans. Constructor-arg is a similar way of wiring the beans, just like we did using property tag. So this is how we can define and wire beans using annotations with minimal boilerplate code. Now moving to the last question for today's video. When to use annotations and when to use XML configuration. Let us try to understand both the approaches based on ease of use, maintainability, and performance. Starting with annotations. Annotations are known for their simplicity. They are embedded directly into the code, making it easier to see how the configuration is applied without switching between files. Annotations are more aligned with the convention over configuration principle, due to which it requires less boilerplate code. One major issue that I feel with annotations is tight coupling. It will make your application components tightly coupled with each other and framework. But if your configuration is closely tied to the business logic and unlikely to change frequently, then annotations will be good options for you. Now, enough with the annotations. Let us see when to use the senior citizen XML based configuration. One of the best things that I like about XML based configuration is separation of concerns. XML allows you to separate configuration from the code, which can make the code base cleaner and easier to manage. Another application of Grandpa XML configuration is in legacy system. In older applications or systems that are already using XML configuration, it might be easier to maintain consistency by sticking with XML configuration. And also because in software industry, you don't want to touch something which is already working. So these were few of the use cases of annotation and XML based configurations. Now let us see how do they impact the overall application performance. The first key performance indicator is startup time. Annotation-based configuration can be faster to set up because they reduce the need of external configuration files. However, the actual performance difference is usually negligible because Spring containers still have to perform class path scanning, and after that, a very heavy use of reflection, which can drag its startup time. On the other hand, parsing XML files does add some overhead, but this overhead is typically very small. In the current times, we have very efficient XML parsers, and the time difference compared to annotation-based configuration is usually minimal. One more thing that I like about annotations is it is very easy to read and maintain. Since annotations are part of the code, they make it clear how the configuration relates to the class. This inline approach often makes the code easier to understand and navigate. And frankly speaking, nobody likes to read and understand those complex XML tags and its attributes. Annotations are less flexible for changes because we cannot apply the changes without recompiling the whole code base. XML, on the other hand, are more flexible for the runtime changes as the configuration can be updated without recompiling the application code. Now you need to understand that the overuse of anything is dangerous, and it is true for annotations as well. If overused, annotations can clutter the classes, making it harder to read and maintain as well. Overall, if we talk about these, annotations are typically preferred for simplicity and ease of use. On the other hand, XML-based configuration is useful for projects where configuration needs to be externalized and modified without changing the code base. We can use both approaches together by utilizing the strengths of each based on the specific needs. The performance difference is generally minimal, and it should not be the primary concern while choosing between annotations and XMLs. The choice should be based on the ease of maintenance, flexibility, and project requirements. So these were the set of first 10 interview questions on Spring Framework I have prepared for the freshers or the developers with 0 to 2 years of experience. I hope you like it, and if you find this video useful, don't forget to like, share and subscribe. Also provide your feedback in the comment section. I'll prepare more videos for different experience and difficulty levels. Once again, thank you so much for watching. I'll see you in the next video. Till then, happy coding.